statistical model is used to examine a phenomenon or outcome, the model offers an explanation. The model can't offer a full explanation. Therefore, there's an unexplained amount, which is called the error. So the error is part of the model estimation. Bias, on the other hand, is obtaining misleading results from the model estimation. So the bias can arise from sample selection. So the sample plan has to match with the problem in hand and the solution sought. Second is the way data are collected. The data has to be data-based rather than data-informed or influenced, because then the data can get contaminated and might not be evidence-based. Third is using an inappropriate statistical model for the analysis. So let's look at using statistical model for analysis. There are two suites of research methods offered in statistics: parametric and non-parametric suites. The parametric tests are based on normal distribution of estimates. And there are 4 general assumptions to use parametric tests. The first one is additivity and linearity. So when we investigate an outcome using more than one independent variable, explanation offered by each independent variable about the outcome should have a linear relationship with the outcome, should linearly change with the outcome as the independent variable increases. Then the outcome variable should also change in a linear fashion. The second is that these variables should be categorical. If they are categorical or qualitative variables, they can have only 2 possibilities, so 2 categories, or continuous variables. The model variables do not correlate with variables outside the model. And the variables that are inside the model, the explanation offered by variable 1 to the outcome and the explanation offered by variable 2 to the outcome are separate linear and also additive. The second aspect is the normality. What we mean here by normality is the parameters estimated using independent variables. The parameters, their estimation should be normally distributed. That means as the independent variable changes, there's an estimation of the parameter, they are normally distributed. The second of that is that the errors in the model, the errors estimated also should be normally distributed. These two aspects of normal distribution of the parameter estimates and the error estimates lead to making correct estimates of the confidence interval for hypothesis testing. Because we take a sample, from the sample we try to make inferences about the population using confidence interval. For example, that the sample mean lies within a certain confidence interval that reflects the population mean. And for hypothesis testing and the significance testing, to make inferences that our inferences are 5% significant, or we are more than 95% confidence that the mean that we found from the sample is outside the estimated population mean. So the estimation about the parameter and the estimation of the errors to be normally distributed, the importance of that decreases as the sample size increases, going with the central limit theorem, because then the sample tends to represent the population. In such situations, our focus should be on the outliers in our sample. The third aspect is the homogeneity of variance. That means when the independent variable varies, the variation that occurs at a given point in the independent variable on the outcome variable should be consistent along with the change in the independent variable. But if that variation keeps changing, that means it is inconsistent, then the variance of the outcome variable is not homogeneous, it is heterogeneous. So homogeneity of the variance of the outcome variable is the third aspect. The fourth aspect is the independence of the errors. They are the variables that are not included in the model and all other factors. They should not have any dependence on the outcome variable. They should not have any dependence on the independent variables. For example, as the independent variable keeps increasing, the errors should also spread in such a way that they are consistent. Errors are the differences from the estimated predictor line. They are the vertical differences. They should be consistent. If they are not consistent, then errors are not independent. So the fourth aspect is the independence of errors. So why is it that these aspects are important? And how would this bias influence inferences? The first is the estimating the parameters. Is a parameter estimates shows the relationship or the strength of the relationship between independent variable and the outcome variable. That estimation to be accurate, those assumptions should be made. The second is the estimation of the standard errors of the mean. It is through the standard error of the mean that we estimate the confidence interval correctly. So to estimate the confidence interval correct, then we must meet the assumptions. The third, that's resulting from estimation of the standard error of the mean and the confidence interval, is the significant test. For us to make that our inferences about the sample mean lies within the population or outside the population, at 5% significance level, or with 95% confidence level, these assumptions should be met.